Hey, many of you love Prisma as your ORM, and let's take a look at the 5.0 version that is finally here and the, to be honest, pretty impressive performance benefits that it brings. However, with the new implementation, there's one small problem. But before looking at that, let's take a look at the performance benefits that you get. So let's see what the hell the problem with Prisma even is. We are running a simple select star from customer, and Drizzle performs this at about 8 milliseconds, slightly above it. What does Prisma do? Surprisingly, Prisma does this at 3.5 milliseconds in a way shorter time than Drizzle can. And this is before the performance optimizations of Prisma 5. So why the hell would you use Drizzle? That seems pretty bad. But take a look at this. What happens when we use prepared statements in Drizzle? Well, they do it in less than 2 milliseconds, way faster than Prisma. And what the preparation means is as long as the serverless environment has been instantiated, as long as the function is warm, you can benefit from not having to reconcatenate the query string. So there's a bit of performance benefit you have to preparing statements. So let's switch over to one more realistic use case. Rarely would you just want to select everything from customer and that's it. You pretty much always have a condition where the ID matches a certain property, and that's the way more important benchmark. You can see the durations are on average much longer, and let's see what Drizzle performs like. Well, we can see it's about 130 milliseconds in Postgres to run this query against our database. And how does Prisma perform this really important, very standard use case? Well, it's off the charts. It's way up here at about 180 milliseconds. So you can see there's a massive performance overhead we get with Prisma. And what about Drizzle prepared statements that tend to perform way better than the normal Drizzle anyways? Well, as you can see, the prepared statements are really fast. In fact, the fastest of the benchmarks available. We can see they come around at 90 milliseconds, which is really fast. Here you can see a rough timeline on how a Prisma query is performed. And you can see there are some really big inefficiencies. Not the import. The import takes some amount of time, but it's fine. But take a look at this, the connection and the actual query together. I've marked the rough time spots, and if we imagine there was a 3-second mark, it would be around here, let's say. You know, this is where the 3-second mark goes. So this entire query with the import, connection establishment, and actual query against the database, which is the important part. The other stuff is not that important, takes altogether about 2.5 seconds only for the first call of this query for the cold start, which is really inefficient. And you know the biggest problem with the actual query is the actual query of this is this little slot. This is the call against the database, this orange thing right here. And this right here, this massive inefficient block, is a certain parsing that Prisma does under the hood to validate queries in their internal query engine. This is the inefficiency. And do you know what the Prisma team did in Prisma 5? Well, they went ahead and deleted this and moved this over, significantly reducing the time it takes to perform a query against the database. But how did they do this? So the short answer is, instead of using something that sucks, they're now using something that doesn't suck. Now, a more detailed answer would be that the Prisma client communicates with the Rust binary engine. And how they do that before 5.0 was in a GraphQL-like protocol. And that communication, that protocol has now been replaced by a JSON protocol. What that leads to is a massive decrease in the communication time it takes between those two, the Prisma client and the query engine, moving them way closer together, massively reducing the time you just saw. On a side note, another really cool change they introduced is that the connection establishment now happens simultaneous with the schema transformation. Beforehand, even though there was no real reason for it, those happened sequentially, but now they're parallel. Imagine it like a promise.all, where you await two things at the exact same time that don't rely on each other, really leveraging some performance benefits. And that's where we land in chapter 2, and that is optimizing the connection. How do we do that? Well, in the test runs that Prisma did, this server making the request was hosted in EU Central 1. And you see the problem, the database answering the request coming from the server was hosted on US East, US East 1. And that is a really big problem because establishing a connection across like half the world takes really long, of course. So what Prisma did is move the server closer to the database, therefore significantly reducing the connection time it takes to establish a connection from the server to the database, which then leads to us being able to make the request, the actual query, what matters, earlier. If we can reduce the time it takes to make a connection, which we can by moving these closer together, then we can start making the request what actually matters, the find many invocation that we're running in this test, way earlier. So those were the most important changes. If you take a look at all changes, we end up at around 300 milliseconds after, and before the cold start for Prisma was about 2.6 milliseconds. So we've got a massive performance edge for cold starts in 5.0. Hell yeah, I hear you chanting. Those changes are amazing. And I'm not gonna be that guy. I agree with you, they are really cool. However, in the beginning of the video, I mentioned there's one small problem with them. And that's not a new problem, that's an old one they didn't address in this update. So don't get me wrong, I am not against innovation at all. I think what the Prisma team has done here is really, really nice. Just the problem though, you remember in the Rust binary engine, when you join tables in Prisma, it literally goes to every single table, gets the data, does a bunch of reads unoptimized, then mashes that together in the Rust binary engine and gives you the result. Well, they didn't really address that in their current update, mainly because that wouldn't really improve the cold start at all. It's a really separate issue from that. So I hope that's one thing they might address in their future versions, because that's what Drizzle ORM does way better, where only one single query is sent to the database that is really optimized. You can prepare those statements, get back the result, and resulting in less reads to your database and less cost for you in the end if you want to scale this up really high. All in all, really cool changes. You can try them out today if you want. Just install Prisma, initialize it, and you'll get the 5.0 version in your package.json. I just tried it out and it works beautifully. That's gonna be it for me for this video. I'm gonna see you in the next one. Have a good one and bye bye.